Welcome viewers. Today we will discuss the renin-angiotensin-aldosterone system. It is the part 1 of the renin-angiotensin-aldosterone system in which we will discuss how the renin release from the body. Before going to discuss the renin-angiotensin-aldosterone system, first of all, we should know that what is the duty of this system. Duty of this system is to maintain the blood pressure and blood volume. To understand the renin-angiotensin-aldosterone system, how the blood pressure and blood volume is maintained, first of all, let's discuss this diagram. Suppose it is a circulatory system of the body. Let's disturb the volume and the pressure. There is a patient who got a road accident. He is losing blood. He is bleeding. Suppose it is a circulatory system. The organs which are going to play the vital role in this renin-angiotensin-aldosterone system are the CNS, kidney, liver, pulmonary circulation or the pulmonary circulatory system, and adrenal cortex. Now let's start to discuss one by one. What really happens when patient is bleeding? Naturally, the blood pressure is going down. The blood volume is also going down. If the patient is bleeding, blood pressure is going down, the blood to the kidney will increase or decrease. It will definitely decrease. Means renal perfusion also decreases. Whenever there is reduced renal perfusion, then veins from the kidney start bring enzyme in the blood called renin. First of all, we will study that by reducing the blood pressure, how the kidney start producing the renin. For this purpose, I will bring one nephron out from the body, because nephron is the apparatus which is supposed to release the renin. There are so many nephrons in the kidney. One kidney has 1.2 million nephrons. Patient is bleeding. Naturally, blood is coming to the kidney is less. Of course, blood flow to the nephron is less. So, efferent arterioles has poor blood flow. Now, there is a very interesting thing. Nature has put blood pressure measuring devices with this nephron. Which is the blood pressure measuring devices. As the efferent arterioles approaches to the glomerulus, the smooth muscles become altered. They are no more normal smooth muscles. They are very specialized smooth muscles. This group of specialized smooth muscles which are present in the wall of the afferent arterioles, this is blood pressure measuring device called baroreceptors. The whole group is given a special name, that is the Pocicin. Now what is the Pocicin? Pocicin are made of afferent arteriolar smooth muscles which are able to measure the blood flow of the nephron or blood flow to the nephron. Whenever blood flow to nephron become less, these baroreceptors or Pocicin starts releasing renin in the blood. It means there is a double action. Number one is to measure the blood flow, and number two is to release the renin. It means they are acting like endocrine glands. So every nephron has small endocrine system with it. Means as the blood flow is less, the afferent arterioles, as the blood flow is less in the afferent arterioles, blood pressure is less. These blood pressure measuring devices, baroreceptors or Pocicin, starts to release the renin in the blood. Another mechanism of releasing the renin is also there. First, understand the normal. Normally, when the blood moving through the glomerulus capillaries, there is some filtration done. Their glomerular filtration. It is the glomerular filtration, that is known as GFR, glomerular filtration rate. This glomerular filtration normally has lot of sodium and many other substances. This filtered material is start going down because it has lot of sodium. Nephron cell take the sodium back to the body, and you know well, about 60% sodium reabsorbed by the proximal convoluted tubule, and about 25% of sodium is reabsorbed by the thick ascending loop of Henle, and about 10% of sodium is reabsorbed at the end part of the thick ascending loop of Henle and beginning of the distal convoluted tubule, and remaining 2 to 3% part is in the collecting tubule, is reabsorbed of the sodium. Here nature has put a beautiful function. Here some tall, dark looking modified cells of nephron present at the end part of the thick ascending loop of Henle and beginning of the distal convoluted tubule, which are known as Macula Densa. These are also known as the chemo receptors. These cells love to taste sodium. They are sensitive to the sodium. In other words, they are sodium sensors. Let's see, Pokesin is a pressure sensing cells or system, and Macula Densa are the chemoreceptors and they are sodium sensors. Baroreceptors plus chemoreceptors together make a whole apparatus that is called juxtaglomerular apparatus. Both are attached with the connecting tissues. These are the connecting tissues. Now, person is bleeding. When the blood pressure is going down, blood flow is going down. When blood flow is less, baroreceptors are activated in the juxtaglomerular apparatus and they release renin. Meanwhile, when your blood flow is less, glomerular filtration rate is more or less. Obviously it will be less. If less, then blood coming into this filtration is also more or less, definitely less. If filtration is very less, then fluid will move through the lumen rapidly or slowly. So, the luminal cells which are working on this luminal fluid, the luminal cells which are working on this luminal fluid, they have more chance to work or less chance to work? Definitely, they have more chance to work. What is their work? They have more chance to work on this less sodium, less fluid to reabsorb this sodium. If sodium is less reabsorbed, they have more reabsorbed because the lumen is more working due to its less flow. The sodium is coming in a very less quantity in this luminal fluid, in this lumen or the in this nephron. So, when blood pressure become less, glomerular filtration become less. Luminal flow become less. The luminal cells extract extraordinary amount of sodium, and by the time little fluid reaches to the diluting segment, it's a diluting segment, it has less than normal amount of sodium. This portion will have the less than normal amount of sodium. Macula densa, as you know well, these are the sodium sensors. Then the proximal part of the nephron work on the slowly moving fluid. This proximal portion of the nephron work on the slowly moving fluid, extract too much sodium, less sodium reach to the sodium sensing device, that is the macula densa. When macula densa feels the sodium is coming in a very less quantity, it become superactive. They become superactive and request to the Pocassin that please listen to us. There is a very little amount of sodium coming to us. There is something wrong. There is problem with GFR. Probably blood is not coming well. Probably blood is not coming well. So please release more renin. So renin release further augmented. Renin has become, here we can understand that the renin has been released under the two influences. Number one is under pressure change by this baroreceptor, and renin has been released under the sodium change due to this chemo receptor device, macula densa. Pressure measuring device baroreceptor is a derivative of efferent arterioles. Sodium measuring device is the derivative of nephron cells. Sodium measuring device is a derivative of nephron cells. These are interconnected with the connecting tissues. Function of renin is to bring the blood pressure back. The function of renin is to bring the blood pressure back and blood volume up, so the patient doesn't die. Example, patient has lost 1 liter of blood. Then somehow blood pressure and blood volume should be maintained. We will talk about how the renin does it in the next video. Thanks for watching. Stay tuned for the more videos of renin, angiotensin, aldosterone system and the other medical informations.